This is the Ducati Superleggera V4. Its frame is made entirely of carbon fiber. Not carbon fiber panels over an aluminium skeleton, the frame itself. The primary load-bearing structure connecting the steering head to the swing arm pivot is woven carbon fiber, a world first for a production motorcycle. And that frame also serves as the engine's airbox. They are the same single piece of material. Remove one and you've destroyed the other. Ducati built 500 of these. Each one costs $100,000, and every allocation was claimed before most of the world had finished reading the press release. The Superleggera V4 was announced at the EICMA show in Milan in 2020. Within hours of the reveal going public, all 500 units were reserved. Not because buyers had seen the bike in person, most hadn't. They committed on the specification sheet alone. On the numbers: 234 horsepower, 152 kilograms dry. An engine whose bore, stroke, firing order and valve actuation system are shared directly with the Desmosedici GP, the machine Ducati races in MotoGP against the best factory teams in the world. At the time of launch, Ducati CEO Claudio Domenicali described the Superleggera V4 as the most extreme road motorcycle ever conceived by Ducati, which is not a sentence you'd put in a press release unless you were fairly certain you could prove it. The question is, how close can a road-legal motorcycle actually get to a racing prototype? And did Ducati actually get there? In this video, we're going to find out precisely. We've recreated the Ducati Superleggera V4 in full, the carbon fiber monocoque frame, the Desmosedici Stradale R engine, the integrated aero package, and every system between them, to show you what $100,000 of Italian racing engineering actually looks like. This is bespoke. Start with the dimensions, because on this motorcycle, even the dimensions are a statement. Overall length, 82 inches, 2,083 millimeters. That's roughly the length of a standard king-size bed. Wheelbase is 56.6 inches, 1,438 millimeters. Seat height is 33.5 inches, 851 millimeters. These are race geometry numbers. The riding position this creates, weight forward, wrists loaded, knees clamped into the tank, is not for commuting. It was never designed to be. Front tyre, 120/70, 17 Pirelli Diablo Supercorsa SP. Rear, 200/60/17. The Supercorsa SP is Pirelli's road-legal tyre with the compound profile closest to their race slick. Ducati didn't choose it for the branding. They chose it because the chassis. Engineering of the Superleggera V4 demands a tyre capable of transmitting 234 horsepower to the road without disintegrating, and very few tyres qualify. Now, the number that defines the machine. Dry weight, 335.5 pounds, 152.2 kilograms. For context, a standard Ducati Panigale 4S weighs around 195 kilograms wet. The Superleggera V4 weighs 152.2 kilograms dry. That's a 43 kilogram difference, stripped out of the same fundamental motorcycle through materials engineering alone. 43 kilograms is the weight of a fully equipped soldier's pack, a large suitcase, or, if you want a more unusual comparison, roughly the same as the engine from a standard Kawasaki Z400. Ducati removed that mass by replacing every component that could legally and physically be made from carbon fiber with carbon fiber, and then went back and repeated the process. Power output: 234 horsepower at 15,500 revolutions per minute, 175 kilowatts. Torque: 90.7 pound-feet, 123 newton-meters, at 11,500 revolutions per minute. Power-to-weight ratio: 1.54 horsepower per kilogram. A Bugatti Veyron, in standard specification, produces around 0.54 horsepower per kilogram. The Superleggera V4 produces nearly 3 times the power-to-weight ratio of a car that costs 20 times as much. And it fits in a standard parking space. I have no follow-up comment. The number speaks for itself. The top speed sits at around 186 miles per hour, 300 kilometers per hour. That figure is an engineering estimate rather than a verified record, because the handful of Superleggera V4 owners who have approached those numbers have done so on closed circuits. What is measurable is the 0 to 62 miles per hour time, somewhere around 2.8 seconds with launch control engaged. For reference, a Porsche 911 Turbo S, a car that costs significantly more and represents the absolute current art in production sports car performance, runs the same figure in 2.7 seconds on 4 wheels, with a gearbox engineered specifically for maximum acceleration. The Superleggera V4 does it on 2 wheels with a chain drive, while you're wearing a helmet and hoping for the best. Total production, 500 units, all sold, all gone. One for every year between the fall of Rome and the coronation of Charlemagne. If you want one now, you're looking at the used market, and the used market has noticed the scarcity. The carbon fiber frame. On a conventional motorcycle, the frame is a welded structure of aluminium castings and extruded tubes. It carries load, connects the major assemblies, and gives the suspension something to react against. Aluminium alloy frames have been the industry standard since the 1980s because they're strong, acceptably light, and inexpensive to manufacture at volume. They work well. Nobody in the industry was particularly unhappy with them. But they're not carbon fiber. Carbon fiber has a specific stiffness per unit of weight, that aluminium cannot approach. A carbon fiber component of equivalent cross-section to an aluminium one is both lighter and stiffer. The difficulty is that producing carbon fiber structures requires expertise in composites engineering, precise autoclave curing, and quality control methods that most motorcycle manufacturers have never needed to develop. Ducati developed them anyway. In partnership with Dallara, the Italian manufacturer whose carbon fiber chassis work underpins Formula One, IndyCar and Le Mans prototype racing, they engineered the first carbon fiber monocoque frame for a production motorcycle. Not a concept, not a prototype. A motorcycle that 500 people can actually register and ride. The frame weighs 8 kilograms, that's 17.6 pounds, for a structure responsible for connecting 234 horsepower of engine torque to the road through steering geometry, suspension linkages, and a swing arm pivot under repeated braking, cornering and acceleration loads. 8 kilograms is extraordinary. The equivalent aluminium alloy frame on the Panigale Vive 4R, the track spec version of Ducati's flagship, weighs approximately 12 kilograms. 4 kilograms saved from the frame alone. The carbon fiber doesn't stop there. The swing arm is carbon fiber. The wheels are carbon fiber, manufactured by Marcassini using the same filament winding process used in aerospace components, each wheel inspected ultrasonically before fitting to verify internal integrity. Carbon fiber wheels save approximately 1.3 kilograms compared to forged aluminium equivalents, which is a meaningful number when you understand that unsprung weight not supported by the suspension, affects handling more directly than any equivalent reduction in the static mass of the motorcycle. Every gram you remove from a wheel is worth several grams removed from the frame. Ducati removed as many grams as the regulations would allow. Here's the detail nobody explains clearly. The carbon fiber frame also serves as the engine's airbox. The hollow interior volume of the frame, sealed and channeled through precision intake openings at the front of the nose, delivers pressurized air directly to the throttle bodies at the top of the Desmosedici Stradale R engine. Ram air effect at speed, where forward motion forces air into the intake at above ambient pressure, works through the frame. The frame breathes. There is no separate airbox component anywhere on this motorcycle because the frame is the airbox. Engineering those two functions into one piece of material took years of development. The frame must be torsionally stiff enough to support high-speed cornering loads and rigid enough at every joint to maintain suspension geometry under hard braking. It must also be sealed precisely enough to function as a pressurized air plenum without leaking around any of the interface points where engine mounts, swing arm bearings and suspension linkage pivots pass through the structure. Those are competing requirements. Carbon fiber, laid by hand in a mold by composites technicians in Dalara's facility and cured in an autoclave, is the only material that can satisfy both simultaneously. The layup process matters. Each sheet of pre-impregnated carbon fiber cloth is placed into the mold manually, with the fiber orientation at each layer chosen specifically to direct stiffness where the load analysis demands it. Different zones of the frame carry different types of stress. Torsion near the steering head, bending along the main backbone, complex shear loads around the swing arm pivot, and the carbon fiber orientation is adjusted zone by zone to handle each one. You can't do this with aluminium. You can't machine varying stiffness directions into a casting. Carbon fiber is the only structural material that allows a designer to put the stiffness precisely where it's needed and nowhere else. Now, the engine. The Desmosedici Stradale R is a 998 cubic centimeters, 90-degree V4 with a bore of 81 millimeters and a stroke of 48.4 millimeters. Those are exactly the dimensions of the Desmosedici GP, the engine in Ducati's MotoGP machine. Same bore, same stroke, same firing order. In MotoGP, the two front cylinders fire 90 degrees apart, followed by a 270-degree gap, then the two rear cylinders. Ducati calls this the twin pulse sequence. It creates a torque delivery characteristic that rolls rather than spikes, more tractable above 10,000 revolutions per minute than an even firing 4, and audibly distinctive in a way that Ducati fans refer to as sounding like a V-twin that's been educated beyond its expectations. The crankshaft rotates counter to the wheels. This requires explanation because it sounds either arcane or fictional, and it's neither. On a standard motorcycle engine, the crankshaft spins in the same direction as the wheels. A spinning mass generates a gyroscopic moment, a resistance to changes in angular orientation. On a conventional motorcycle, this gyroscopic effect from the crankshaft adds to the gyroscopic effect from the wheels, and the combined result slightly resists the bike leaning into a corner. Reverse the crankshaft rotation and its gyroscopic contribution cancels part of the wheel gyroscopic effect rather than adding to it. The motorcycle steers more keenly. It turns in faster. At the speeds the Superleggera V4 operates, the difference is felt in every corner. This is standard practice in MotoGP. It is not standard practice on anything you can ride to work. The valve system is desmodromic. Ducati has used desmodromic valve actuation since the 1950s, and it remains a genuine competitive advantage rather than a heritage affectation. In a conventional engine, valves are opened by a cam lobe pressing on a rocker arm and closed by a return spring. Springs work until they don't. At very high RPM, a spring may not be able to return the valve to its seat fast enough before the next cycle begins, causing valve float. Valve float at 15,500 revolutions per minute produces outcomes nobody wants. Ducati's desmodromic system closes the valve mechanically. A second rocker arm, actuated by a dedicated closing cam lobe, physically pulls the valve back to its seat. No spring, no float, no RPM sealing from that source. The result is an engine that revs to 15,500 revolutions per minute cleanly and produces 234 horsepower while doing it. Fit the racing exhaust, remap the ECU, and remove the catalytic converter required for road certification, all of which are available as a Ducati-supplied track kit, and the figure rises further still. The Desmosedici Stradale R was also developed with Ducati Corse, the racing division, rather than the road bike engineering team leading the project. That's an important distinction. When motorcycle manufacturers develop road-going versions of racing engines, the usual process runs in one direction. Take the race engine, soften it, re-rate it for emissions, fit it in a road bike. The Superleggera V4 ran that process the other way. The MotoGP team's knowledge of the Desmosedici GP, what works at 15,000 revolutions per minute for 45 minutes in a race, informed every decision about how the Stradale R was designed. Oil scavenging systems, titanium connecting rods, titanium intake and exhaust valves. These aren't race features bolted onto a road engine. They are race features that have been made to comply with road certification requirements. The compliance happened to the race engine, not to the road engine. Each Desmosedici Stradale R engine is bench tested before installation. Not sampled, not spot checked, every single engine. Ducati's technicians in Bologna run each unit on a test cell, verify the output, document the results, and then install it in the motorcycle. The test cell printout goes with the bike. Your certificate of authenticity, signed by CEO Claudio Domenicali, references the specific engine number that sat on that bench. When he said at the EICMA, reveal that the Superleggera V4 carries the maximum technical knowledge that Ducati's MotoGP program has developed, this is the kind of process he was referring to. Not rhetoric, procedure. If you're enjoying this breakdown, subscribing now means you don't miss the remaining episodes. There are 8 more, and they escalate significantly from here. The aerodynamics. Winglets on motorcycles are often theatrical. They look aggressive in photographs, generate some token downforce, and function primarily as a signal that the manufacturer has thought about aerodynamics. The Superleggera V4's winglets are not those winglets. At 270 km per hour, 168 miles per hour, the integrated winglets generate 30 kilograms of downforce. That's 66 pounds pressing the front tire into the road at a speed where most motorcycles are becoming light and imprecise. These winglets weren't designed on a drawing board and validated in a road test. They were developed in the same wind tunnel facility Ducati uses for their MotoGP program, by the same aerodynamicists on the same analytical tools. The profiles are specific to this motorcycle's geometry and its speed range. They don't create drag in exchange for downforce. They produce a favorable lift-to-drag ratio across the operating range. At lower speeds, the downforce effect is minor. Above 200 km per hour, it becomes significant enough that riders consistently describe the front end as feeling unusually planted, more composed under braking, more confidence-inspiring through fast direction changes. The winglets are not adjustable on the standard motorcycle because they've been optimized for one configuration. The track kit includes alternative winglet profiles for circuit use. Suspension is Öhlins front and rear, but not standard Öhlins equipment. The front forks are NPX 25.30, pressurized units, a specification co-developed with Ducati specifically for the Superleggera V4's carbon fiber frame. An aluminium frame has torsional flex characteristics that inform how suspension is tuned. The frame moves slightly under load, and the suspension works with that movement. A carbon fiber frame is effectively rigid. The suspension calibration, appropriate for one, doesn't transfer to the other. Ducati and Öhlins spent considerable time developing settings that work with a chassis that doesn't flex. The rear is an Öhlins TX36, fully adjustable, spring preload, high-speed compression, low-speed compression, and rebound independently. At the circuit, with a data logger and a suspension engineer, the setup potential of this rear shock is essentially unlimited for the purposes of road-legal motorcycle racing. You could spend a testing day just on the rear shock and still not have exhausted its range. Brakes, Brembo-Stylmer calipers, front and rear. Monoblock construction, titanium pistons, 4 radially mounted pistons per caliper at the front. Front disc diameter is 330 mm, 13 inches. Bosch cornering ABS, fed by a 6-axis IMU updating at 1,000 times per second, adjusts braking pressure independently at each wheel based on lean angle, deceleration rate, and wheel speed difference. You can brake hard while leaning. The ABS knows the difference between a wheel beginning to lock and a wheel encountering a surface change and responds accordingly. This is technology borrowed from MotoGP. On the Superleggera V4, it comes fitted from the factory. The cockpit is severe. Clip-on handlebars sit below the upper fork clamps, loading significant weight through the wrists. Foot pegs are rear set. The seat is narrow, firm, and uncompromising, not because foam is expensive, but because a rider who shifts around in the saddle loses their reference points for braking markers, corner entry points, and weight transfer. This cockpit was designed for someone who knows exactly what they're doing, knows exactly where they're going, and doesn't intend to move unnecessarily while doing it. The TFT display is 5 inches. In road mode, it shows everything: speed, RPM, gear, fuel level, lean angle, throttle position, tire temperature readouts, suspension data. In race mode, the display strips back to speed, gear, and RPM in large numerals, with a shift light sequence across the top. The principle is the same one that governs the rest of the motorcycle: remove anything that isn't essential to the task. The riding modes are Race A, Race B, Sport, Street, and Wet. Each mode adjusts power delivery character, engine braking intensity, traction control sensitivity, and wheelie control threshold simultaneously. Race A assumes you know what you're doing and adjusts settings accordingly. Maximum power. Minimal intervention, engine braking at its strongest. Wet assumes the opposite and adjusts every parameter to keep the power delivery as gentle and predictable as possible. You can switch modes on the move via the left handlebar switchgear without releasing the throttle. This is also borrowed directly from MotoGP, where riders change electronics maps mid-corner during races. The Superleggera V4 makes that possible for a private owner on a public road. Whether you need it is a separate question. The exhaust is a Krapovich titanium as standard. Not optional. At full throttle, past 10,000 revolutions per minute, the note is not a sound so much as an event. Motorcycle journalist Michael Neves, who tested the Superleggera V4 at Mugello as part of MCN's first international ride evaluation, described the full throttle noise as the most extraordinary thing you'll hear from a road motorcycle. Having listened to recordings taken from cameras mounted on the bike during that session, I'd say he was choosing his words carefully rather than exaggerating. So, the honest verdict: the Ducati Superleggera V4 is the closest thing to a factory MotoGP machine that has ever been registered for public road use. The shared engine architecture isn't marketing language, it's literal. The carbon fiber frame is a genuine engineering first that produces genuine handling advantages at the limit. The aerodynamic package was developed in real wind tunnel conditions and generates real measurable downforce. The build quality, by every independent account and by any reasonable physical inspection, is exceptional. And the electronics package is the most sophisticated system Ducati has produced for road use. What it doesn't do: it isn't comfortable for more than 30 minutes unless you're in race gear and mentally prepared for what you've chosen to ride. This isn't a small caveat. Road riding, especially in cities, on imperfect surfaces, in traffic, puts a rider in sustained, awkward positions that a race geometry bike doesn't accommodate. The Superleggera V4 is physically demanding in a way that distinguishes genuine track day weapons from motorcycles that only look like them. The Desmosedici valve service interval, 7,500 miles, performed by a Ducati authorized workshop, is neither cheap nor quick. Some buyers were surprised by the severity of the riding position, which raises a quiet question about whether every one of the 500 buyers fully understood what the specification sheet was describing. And at $100,000, it occupies a price point where any mechanical issue, however minor, carries the psychological weight of something that really, genuinely should not be going wrong. But here's what the Superleggera V4 actually proved. A production motorcycle with a carbon fiber chassis, a counter-rotating MotoGP-Derived V4 engine, an integrated aerodynamic package, and fully adjustable MotoGP specification suspension could be engineered, road certified in 47 countries, hand-assembled in Bologna, and sold to the public. That had never happened before. Manufacturers noticed. Several have since patented carbon fiber frame elements for road-going products. Ducati moved the technical frontier of what a production motorcycle can be, and the industry is still catching up. In the last episode, we looked at a very different approach to the $100,000 motorcycle, Arch Motorcycle Company's Method 143, where every unit is physically fitted to one specific body, ridden and approved personally by Keanu Reeves before it ships. Same price bracket, completely different engineering philosophy. Worth watching if you haven't. Next time, we're looking at the most expensive motorcycle ever sold at auction. $11 million, one unit. And we're going to find out whether anything about the engineering behind it actually justifies that number, or whether the price is entirely a function of who it was sold by. This took a long time to research accurately. If you find any errors in the technical detail, let us know in the comments. We read every one.